Welcome to finding integrating factors in theory. So recall, if we have an equation m dx plus n dy equals 0, which is not exact, then we might use an integrating factor to force it into an exact equation. So then we might use an integrating factor mu of xy to force it into an exact equation. So in other words, we want mu such that mu times, in parentheses, m dx plus n dy, and parentheses, equals 0 is an exact equation. Right? So the question becomes, how do we find such a mu? So the first thing we need to do is just figure out what does this equation mu times m dx plus n dy equaling 0 being exact mean for mu. So what we have here is note if mu times, in parentheses, m dx plus n dy all equal to 0 is exact, then we have just multiplying out mu times m multiplying dx plus mu times n multiplying dy equals 0 is exact. Right? These are just the exact same equation here. So this means then a partial with respect to y of mu times m must be equal to the partial derivative with respect to x of mu times n. Right? This we know just simply by an exact equation. Right? But the partial with respect to y of mu times m, so using the product rule, we get that, let's see, the partial with respect to y of mu times m would be the partial with respect to y of mu times m plus mu times the partial with respect to y of m. So that's our left-hand side. On the right, the partial with respect to x of mu times n, we would have the partial with respect to x of mu, then times n, plus mu times the partial with respect to n of x. So now to make our lives easier, let's go ahead and assume that mu of xy can be written as a product of a function of x times a function of y. So in other words, we can write mu of xy as p of x times q of y. Then note that the partial with respect to y of mu would just be p of x times q prime of y, since p of x is simply a function of x, and the partial with respect to x x of mu would be just p prime of x times q of y. Again, q of y is simply a function in y. This means then mu y times m plus mu times my equaling mu x times m plus mu times nx. This can be rewritten as, let's see, mu y is p of x times q prime of y, and then that is multiplying m. Then we have plus mu is p of x times q of y. That is multiplying my. I'm going to shift this whole thing to the side in hopes I can write this all in one line. Then we have mu x is p prime of x times q of y. That is multiplying m. And to that we add mu, which was p of x times q of y, multiplying nx. We can go ahead and rearrange this a little bit, moving terms around from side to side. Putting all of the partials with of m and n on the left. Again, moving the terms. We can rewrite this as p of x times q of y times my minus p of x times q of y times nx is equal to, I apologize, my screen is not updating. One moment. All right, so on the left, we have the two terms multiplied by p of x, q of y. And then on the right, we will go ahead and put our terms that include a derivative of either p or q. So this is equal to p prime of x times q of y times n minus p of x times q prime of y times m. If we then divide through by p of x times q of y, we get on the left simply my minus nx is equal to, on the right, p prime of x qy divided by p of x qy. The q of y's cancel out, and so we would just have p prime of x over p of x multiplying our n, and then we are subtracting p of x q prime of y divided by p of x q of y. The p of x is canceled out. We just have q prime of y over q of y times n. Sorry, times m. There we go. So now we're going to play some tricks. So to make life even simpler, right? Let's go ahead and say if my minus nx over n is a function of x, then we can go ahead and take our q to be identically 1. So if my minus nx over n is a function of x, we can assume that q of y is identically 1. In which case q prime of y is identically 0. Then our equation becomes, then the equation becomes my minus nx is equal to p prime of x over p of x times n, right? And then that minus q prime of y over q of y just goes to 0. Or we can rewrite this as p prime of x over p of x is equal to my minus nx over n. We know how to solve this particular equation, or this particular problem. So the separable equation that's already been separated out, we wind up getting that our capital P of x here is e to the integral of my minus nx over n dx. And if P of x is that, this means that our integrating factor mu of xy is e to the integral of my minus nx over n dx times 1. Again, our q of y was 1. So this is our p of x and our q of y. So we have here our integrating factor. So again, if my minus nx over n is a function of x, I'm going to label it as p of x this time, a function of x. Then we can pick mu of x equaling e to the integral of lowercase p of x dx as our integrating factor. So this is our first fact. If we have my minus nx over n equaling a function of x, then we can quickly find our integrating factor. Similarly, if nx minus my over m is a function of y, right? Then let's assume that p of x is identically 1, and therefore p prime of x is identically 0. Then our equation becomes we have my minus nx is equal to the p prime over p goes to 0. We have a negative q prime of y over q of y times m. Or q prime of y over q of y is equal to nx minus my over m. Again, this solves, solving this, we get similar solution to what we had previously. We again have just a separable equation already separated out. We get that q of y is equal to e to the integral of nx minus my over m dy. And so this means that our mu of xy is equal to p of x here is 1, and then times e to the integral of nx minus my over m dy. So what we get here is if nx minus my over m is a function of y, so we'll write it as lowercase q of y, then we can pick mu of y equaling e to the integral of our lowercase q of y dy as our integrating factor. So we get two nice, convenient techniques for finding integrating factors if one of these two if statements happens to check out. So these are our two simpler ways of finding integrating factors. It will not always be possible to find an integrating factor in this manner. It's not always true that either nx minus my over m is a function of y, or my minus nx over n is a function of x, but this gives us one possible shortcut.